Well, hi everyone. One more example. This is fairly extensive here. Remember, the first thing we want to do is, well, I would like to factor this, and I wonder if grouping is going to work on the top. 2x cubed plus x squared minus 8x minus 4. Let me get an x squared out of here, so that's 2x plus 1. Let's get negative 4 out of here. That's also 2x plus 4. Whoops, 1. 2x plus 1. That's x squared minus 4 times 2x plus 1. And then that x squared minus 4, that's a difference of squares. That's x plus 2 times x minus 2 times 2x plus 1. Alright. So, as I go ahead and factor this, f of x is equal to x plus 2 times x minus 2 times 2x plus 1. This is over. Does that factor? Let me just check one thing real quick here. Okay, I am going to change this to a plus. I'm cheating. The original problem had a plus there, and I just forgot to put that as plus. So x minus 2 times x minus 1. That does factor. We do have a little bit of something happening. So our simplified function is f of x equals, I'm going to leave it factored, x plus 2 times 2x plus 1. I'm probably going to have to get that slant asymptote, I'm going to have to multiply that out again. And I may as well do it now. We'll leave it like this and this. It'll be convenient in both ways. So, what do we got? We got 2x squared plus 1x plus 4x. So 2x squared plus 5x plus 2. Boy, it looks familiar. Over x minus 1. Okay. Now, there's the simplified versions. Okay. Now, we are going to have to address the fact that this thing's going to have a hole in it. The x-coordinate is going to be 2. I'll go back and get the domain here in a minute. Forgot about that, though. And then 2 plus 2 times 2 times 2 plus 1 over 2 minus 1. That's 4. And that's 5. Right? That's 20. So there's a hole at 220. I'm going to have to scale differently when we draw this graph, it looks like. Now, I forgot to talk about the domain. Okay, when I look at this, x can't be 2, x can't be 1. So we can go from negative infinity to 1. We can go from 1 to 2, in between, not on, and we can go from 2 to infinity. Alright, so there's the domain. Got the holes, the y-intercept. Happens when the simplified, it doesn't matter. They'll be the same either way. But with f of 0. And I'm going to use the easier one. So that's 0 plus 2 times 0 plus 1 over 0 minus 1. So f of 0 is negative 2. That's the y-intercept, if I'm doing that right. We have a vertical asymptote. And again, look at the simplified. Do not look at this one. The whole is what the 2 is counting for. The vertical asymptote's after it's been simplified. X equals 1. We have a vertical asymptote at x equals 1. Let's see, zeros. Let's use the factored denominator, or numerator, sorry. X plus 2 times 2x plus 1 equals 0. So x plus 2 equals 0, or 2x minus 1 equals 0. So this is x is negative 2. Let's add 1 to both sides. That's x equals 1/2. Okay, so these are both going to be zeros here. And okay, a slant. I think we're going to have a slant asymptote here. And that's where we did this. So let's, for the slant asymptote, n is greater than m by 1. So we do have a slant asymptote. I'm going to use synthetic division this time to divide that out. I'm going to put 1 in the box and go 2, 5, 2. Let's bring down the 2. That's 2 plus 5 plus 2 is 7. 1 times 7 is 7. 2 and 7 make 9. So when we rewrite this, we're writing 2x plus 7 plus 9 over x minus 1. Our slant asymptote is going to be y equals 2x plus 7. That's our slant asymptote. Alright, now it's time to start graphing. I'm going to just get out another sheet of paper for that. We'll just kind of go back and forth off of this. Okay, I need to get fairly high, so I think I'm going to scale by, I'm going to scale by 5s on the y-axis. 5, 10, 15, 20, 25, 30, 35, 40. I am not going to change my scale. I'm going to go by 1s on the x. Okay, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. Okay. I have a hole at 220. Okay. I have a y-intercept at negative 2. That's about right. I got a vertical asymptote at x equals 1. Okay, zeros at negative 2. Here's a 0. And 1/2. They're right here. And then y equals 2x plus 7. Now keep in mind I have scaled the y-axis down pretty good, so I don't go up to over 1 necessarily here, because if I go up 2 I'm going up 10, and over 1 that makes the slope 10, not 2. So let's be real careful. I need to start at 7. I know this is for the slant asymptote. Okay. I was thinking, boy, that's a problem if I'm down here. But no, this is just for the slant asymptote. So we do kind of go through this point here. Let me just think of a few points. If I put 1, I would be at 9. Remember, y equals 2x plus 7. If I go 2, I'm at 11. Let me go 5. I'd be at 17, right around here. If I go negative 5, negative 10 plus 7 is negative 3. I'd be right around here. So, I think I go through that point right there. With the slant asymptote, kind of looks like this. Now, if we were scaled by 1s, it'd be a lot steeper. All right. It is time to start looking at what's happening here. Okay. Let's checking real quick here. All right, I think I have it's 2x plus 1. Okay, so this is negative 1/2. I think this one's okay. Okay, so that's not the 0. The 0 is right here at negative 1/2. All right. Okay. So, what is going on with this thing? At 3, we've got some good information here. I have a feeling we're close here. We go up a little bit here, and then we start coming back down here toward this asymptote. So I think that's what's happening here. Okay, and I didn't show you a bit of that. Okay, now let me do it. I said start here, go up through this x-intercept, come up and come back down toward this x-intercept and through the y-intercept here, and come back toward this asymptote, toward the vertical asymptote. And then the second part, I was getting ready to think about what's 3 doing here. Remember, we're x plus 2 times 2x plus 1 over x minus 1. So we're talking about 3 plus 2 is 5. 6 plus 1 is 7 over 3 minus 1 is 2. So that's 17.5. So at 3, we are at 17.5. So right around there. So I think we come down here, we hit that hole, we don't go through it, and then we come toward this asymptote here. Okay. Alright guys, take care of yourselves. The scaling was pretty necessary here. I miss you, and I look forward to seeing you again sometime down the road. But just keep up with your studies. You're doing a great job, and God bless you all.